Hey everyone, this is Jamie Dawson Codes, and in this video we're going to be going over LeetCode question 199 binary tree right side view. And for this solution, we're going to be using breadth first search. So before we begin with the algorithm or even the code, let's make sure we understand the problem that we have to solve. So in this example, our job is to go through the binary tree and find all of the nodes that can be seen if you were standing on the right side of the binary tree. Now, you're probably looking like Pikachu right here over here on the right and thinking, oh, this is super easy actually. All I got to do is take in the root node, keep checking right over and over again, and then return an array with all the numbers that I find as I keep going right. Well, in the second example, you're actually going to see it's a bit more complicated than that. Now, in this second example, you'll see that, yes, you are still returning A, C, and F, but as you'll see right here, we're also returning G because nothing on this level right here is blocking G, so that node right there needs to be returned. And it even gets a bit more complicated in the third example I'm about to show you. So in this third example, we don't have any right nodes at all. All of the nodes that are in this binary tree are just going left, but nothing is blocking any of these left nodes. They can all be seen on the right, so all four of these nodes need to be returned into an array. So now that you understand all the test cases that could potentially happen, let's jump into the algorithm and explain how we can solve it. To start off, let's talk about how this algorithm is going to work. BFS traverses a tree by level going from left to right. You see how I labeled all the nodes A, B, C, D, E, and F? That's because that's the order in which I'm going to be visiting the nodes. Also keep in mind that as we move through the nodes, we're also going to be keeping track of what level they're on, and that level will be used to help us to find the node that can be seen on the right side. So the first thing we got to do is that we got to create a queue for the BFS solution, and we'll initialize it with the root node, which is A, and we're also going to be initializing it with the level, which is 0. So it would be array inside of an array. We'll also need to create an array called final array. As we're moving through the binary tree, we'll be adding arrays to the final array. And each individual array will represent a level that can be found in the binary tree. For example, the very first array will only contain the value A, representing level 0. The second array will contain B and C, representing level 1, and the last array will represent level 2, and it will contain D, E, and F. Once we are done adding all of the values to all of the arrays, we're going to take every single index, so in this example, 0, 1, and 2, and we're going to find the last value that can be found for every single array inside of final array, and just set that value to that index. The reason we're doing that is because the very last value that can be found in every single array inside a final array is the node that can be seen on the right side of the binary tree. After we do that, we just return final array. So from here, use the built-in shift command to pull out A and 0 and then store them into variables so we can keep track of the node, which is A, and the level, which is 0. After storing the two variables, you need to determine if you can find a 2D array of index 0 inside final array. So it does not exist. So what you need to do is you need to push an array into final array so that that index can exist. Now that the array was pushed into the array, we can push the current value into that space that we just created. We're done updating the final array with the current value, so our last step is to check if the current node has a left or right pointer. It has both, so we push the left first, which is B on level 1, and right second, which is C on level 1. Now that we're at that spot, if you followed along with the last 4 steps, you're going to start seeing a pattern at this point. Use the built-in shift command to pull out B in 1 and store B into current and 1 into level. Check to see if level 1 exists in final array. As you see, it does not, so we need to push another empty array into final array. From there, add the current value of B into the level 1 index representation in the final array. Now check to see if B's right or left pointers are null. Neither of them are, so go left first and add D and level 2 to the queue, and then go right and add E and level 2 to the queue. Use the built-in shift command to pull out C and 1 and store C into current and then 1 into level. Now check if level 1 exists in the final array. So this time, yes, it does exist. So you can just take the current value of C and add it to this index. Check to see if C has either a left or a right pointer. It only has a right pointer, so you can add F and level 2 into the queue. Use the built-in shift command to pull out D and 2 and then set D to current and then 2 to level. Check to see if level 2 exists in final array. Well, it does not, so go ahead and push an empty array into final array. Now that we created that index, all you got to do is take the value D and push it into that space. Now we check to see if the D node has null left and right pointers, and as you can see, both their pointers are null, so there's nothing to push into the queue. Now use the shift command to grab the node E and the level 2 out of the queue. Now we're checking to see if level 2 exists. It does, so take the current value E and push it into that index. Now check to see if the E node has null left and right pointers. It does, so we don't need to push anything into the queue. And for the final time, we're going to be using shift to pull out the node and the level out of the queue. So set the node F equal to current, and then set the level 2 to level. Now we're checking, does level 2 exist in final array? Well, as you can see, it does. So take the current value of F and just add it to this index. And now we got to check if the F node has null left or right pointers. And as you can see, F has no left or right pointers, so there's nothing to push into the queue. So now for the final step of this algorithm. What we're going to do is we're going to take final array, and we're going to loop through this 2D array, grabbing each array one at a time. From there, we will grab an array, find the last value in it, and then just set that entire index to just that value. So see here, we just take A, and we add it to index 0, index 1, and here we have C. Then we set index 1 to C, and then in index 2, we find F, and then we just set the entirety of index 2 to F. So overall, that's the entire algorithm. Let's go ahead and jump into the code. The first thing I want to do is check to make sure that the root isn't empty. So I'll go ahead and make an if statement that returns an empty array if it is. Whenever I'm doing a BFS or DFS solution, I like to code out a basic version of it and then build on top of it. So let's build out a basic version of BFS. I need to make an array called Q and set it to the root. Then I need to continuously check the array until it's empty. I'm going to make a while loop that will check if the length of the array is greater than 0. Inside the while loop, I'll create a variable that will hold the current node and call it current. I'll use the shift command to pull the value out of the 0 index of the queue. Next, you'll need to create two if statements to check if the left pointer and right pointer are set to null. If they're not, then push those values into the queue. Be sure to check left first and then right. Now I'm going to console log the current value just to confirm that I'm getting all of the values in the correct order. The output gives me 1, 2, 3, 5, 4, which is exactly the order that I need. Now that we have that, let's go ahead and build on top of this. To build on top of this, let's start tracking the level. We need to update the queue so it holds not only the root, but the level, which is 0. Be sure to store both values in an array in the queue. Now that we're dealing with two values, let's destructure it by wrapping current in brackets and then adding the variable called level. This will help us get the current node and the current level at the same time. Also be sure to update the if statements where we push the level in the queue. Wrap the values being pushed in brackets, and then make sure you take the level variable and increase it by 1. We're doing this because if we are moving either left or right, we're going to the next level. Under the queue array, create an array called final array. This is the array we'll be returning. We'll be making it into a 2D array, which will then be returned as a 1D array after we're done updating it. Create an if statement that checks if the level exists in the 2D array. If it doesn't, push an empty array into it, and then add the node value into it. Else, just push the node value into the index that already exists. Just to make sure everything is right, I'm going to console log final array. And this right here is correct. It's a 2D array with all of the values stored in their levels. I'm going to create a loop that will grab each array in final array. We just need a loop with the variable I set to 0, and then have that loop continuously going while I is less than the final array length. Inside of the loop, set the final array I to the value that we return in the function we're creating called findLastValueInArray. Pass in each array one at a time. Create the function called findLastValueInArray. Be sure to pass in the array. Create a variable called end that finds the length of the array -1. And then use that variable to find the last value in the array to return it. And finally, return final array and submit it. So that was LeetCode question 199 binary tree right side view. Thank you so much for checking out my video. If you liked this video, please consider subscribing because I plan on making more LeetCode videos in the future.